అన్న ఇది ఓకే. మైక్ చెక్, మైక్ చెక్. ఓకే. మైక్ చెక్. అది
Check. Hello.
Yes, sir. Welcome back, all of you, to the technical session 2 of day 1 of the International Conference ICIFMEDE. For this, we have Professor L. Sivaramakrishna sir as session chair and Dr. D. Pratibha madam as co-chair. It's my honor to introduce our session chair today, Professor L. Sivaramakrishna sir. Dr. L. Sivaramakrishna is presently working as professor in the Department of Mechanical Engineering, University College of Engineering, Usmania University. Currently, he is serving as Director, Center for Product Design, Development and Additive Manufacturing, a center of excellence established under RUSA 2.0. Director, R&D Cell, UCE, Usmania University, and single point of contact for local chapters FIAM NPTEL. Earlier, he has also worked as Director, Office of the International Affairs, Usmania University, and Joint Director of Evaluation, Examination Cell, University College of Engineering. Recently, he received Best Engineering Teacher Award by Institute of Engineers, India, Hyderabad local chapter. His areas of research interest include 3D printing, Industry 4.0, CAD/CAM, CIM, and cloud-based manufacturing systems. He has published nearly 90 research papers. He is also a project monitoring and review committee member of DMRL project on development of metal components using 3D printing technology for defense applications. He also works with MDS Care Hospitals, Banjara Hills, Yashoda Hospital, Secunderabad, and Sri Sai Dental College, Mehboob Nagar, for solving various critical cases related to cranioplasty and maxillofacial surgeries. He is also a member of various professional bodies like member of Institute of Engineers, India, Executive Committee member of Indian Society for Science and Engineering, ISRO local chapter of ISSC Hyderabad, Institute of Smart Structures and Systems IEEES, belonging to Department of Aerospace Engineering, IISc Bangalore, International Association of Engineers, Singapore, Institute of Engineers, India. He is also CFO Task Force member of Telangana State Pollution Control Board. We are pleased to have you, sir, as our session chair. We welcome you, sir. And also, it's my privilege to introduce our session co-chair, Dr. Pratibha Dharmavarapu. Having experience of around 17 years teaching and industry, her expertise is in composite materials and computer-aided engineering. She is here with Anurag University since 2014 and is presently holding a position as Assistant Director, Office of Industry Alliances in the university. She has been instrumental in bringing many industry collaborations, which includes Anurag Satellite Project. We are happy to have you, ma'am, as our session co-chair. We welcome you. Let us start with the presentations. Now I would like to invite uh, Go Gogulamanda Virendra Kumar sir with paper ID 49, paper title Design and Development of a Dual Mode Floor Cleaning 4-Wheel Robots with Manual and Automated Functionality. Sir.
Good afternoon, everyone. I am Virendra Kumar Gokulmanda, an assistant professor, Department of Mechanical Engineering, Swarnandra College of Engineering and Technology, Narsapuram, Andhra Pradesh. So it's an honor to present my paper in this international conference hosted by Anurag University And my special thanks to Arun sir and one of the madam who guided me came to here, and I will start my presentation. So, mic. Sir. So these are the key outlines in my paper. So I'm going to deliver introduction, problem statement, objective of research, key features, methodology, conceptual design, testing and calibration, advantages, future scope, and conclusion. Let's dive into the introduction. This works focusing on designing and developing a cleaning robot with dual mode operations, both manual and autonomous. Actually, it is equipped with a brush and motor systems to drive the motor for cleaning the wet and dry um, floors and dust particles, which is very suitable for the environment such as homes, office, and commercial spaces. So in this work, we are using the microcontroller for controlling and motor drivers for controlling the motors, and a Bluetooth module for switching manual to autonomous operations, and ultrasonic sensor for detecting the obstacles and navigation. By integrating the cost efficiency with adaptability, so this robots providing a practical and well efficient and cleaning solutions to reduce the human efforts and make the environment very clean. So problem statement. Actually, this thought is came to in the year 2022, because in past we have faced problems like pandemic. At the time we are everyone being very hygiene and very clean. At the time, my final year students initiated this project. So under my guidance, actually they did the project. So after that, my colleague, so research coordinator Sanjay Ramaswamy sir, so better you make this paper into convert into this paper. So after that, I convert the project into this paper. So actually, so background of the project is so growing importance of hygiene in modern space. So everyone so thinking about hygienes and cleanness and um, make the spaces very clean, and also the time consumption and labor intensity also the one of the factor we have to consider. So by cleaning and maintaining the spaces by manuals or humans, it will take time and also effort. Another one, rise in demand for automated cleaning solutions. These are the main motive of the project, background of the project. And the motivation is to existing robots are there, but we need some uh, adaptability, and they are very expensive. To consider that factors, so we are tried to make the robot in a effective and adaptable functionality. And these are the objective of the project. So develop a cost-effective cleaning robot. So integrating the dual mode functionality, manual and also autonomous. Ensure the adaptability for the various environments like homes, office, and commercial spaces. By combining wet and dry cleaning mechanisms for comprehensive cleaning. These are key features of the robot. So dual mode operations. First one is autonomous mode. So we are using sensor based navigation and cleaning. And in manual mode, so smartphone operated by humans. So we can control the robot for cleaning. And cleaning mechanism. Integrating the motor with the brush, it will give better results and cost efficiency also. These are the methodology. First one, problems definition, conceptual design, component selection, software development, fabrication and assembly, testing and calibration. These are conceptual design, which is designed in the CATIA V5. These are the components. First one, Arduino. So it is a microcontroller and a Bluetooth module for switching manual and automatic mode. One ultrasonic sensor for detecting the obstacles. And DC motors, actually 4 DC motors, each one 100 RPM, and one servo motor, lithium ion battery, 2, and one motor driver and brush. These are the components which are used: Arduino and Bluetooth module, ultrasonic sensor, motor driver, and DC motor and servo motor. These are the pictures of the project. And testing and calibration. In manual mode, by using a Bluetooth operation, the robot can accurately perform the functions and clean the spaces. In autonomous mode also, by using ultrasonic sensor, it can navigate with different places and detecting the obstacles and clean the floors. And coming to metrics, performance metrics. So obstacle detection accuracy is approximately 100%. And coming to cleaning purpose, cleaning area covered by the robot, manual mode approximately 90%, autonomous mode approximately 80%, because the sensors, so after detecting the obstacle, it will move in a curvature. At the time, some area could not covered by the robot. That's why some accuracy was missed. So advantages of this project: the reduce the manual effort, cost efficiency, adaptability, and dual mode flexibility, and it can work on wet and dry floors also. So this future scope, we can increase the efficiency of the robot by integrating sensors and cameras and NVIDIA modules. Coming to conclusion, so dual mode floor cleaning robot bridge the gap between the manual and autonomous cleaning. to combine the cost efficiency, adaptability, and advanced features to offer the practical solutions. So these robots will give the potential for adaptable and innovation robotic solutions to increase and enhance the daily life. Thank you for this opportunity. Actually, we have prepared this one in a prototype, sir. Actually, so around under 3,000, it came, sir. So we used motors and Arduinos through website Maker Bazaar, so that where we'll get very low cost. So actually, that robots having real-time sensors. And also NVIDIA integration also there, sir. That's why that cost is increased. The NVIDIA software itself around 8 to 10,000 cost. So that is actually using autonomous vehicles and other autonomous robots, sir. Yes, sir. But here some efficiency somewhat little bit reduced. Efficiency in the sense, actually we have prepared initially we prepared the brush by using local brushes which are using for our daily cleaning, and that one integrated with combined with and glue and some more drum shaped one, but that one it will heavy for the robot to move the vehicle. So after that we reduce the brush size, so that's why the distance between the fiber particles very little bit increases, sir. That's why cleaning efficiency reduced. So if you want to make it in a real time and better cleaning, so we should go for better motors. At the time, cost may increase 1 or 2,000 rupees. That time we can get around 5,000. We can get a better solutions. Yeah. Actually, Arduino, it is integrated with Arduino, sir. So motor driver integrated with Arduino, that it is fixed, sir. And the motors is fitted into the motor driver. Actually, it is fixed. Actually, not manually. We can increase and decrease by. As you are claiming that it is for cleaning, isn't it? Yes. So, what type of dust and the things are being cleaned by using this? Actually, the micro dust only, sir. Micro particles. So we are going to collect those things. So, which one, sir? Microparticles. Microparticles means dust like sand at that one. So collecting behind one tray is there, sir. Here one GI sheet is there. So tray like one.
To calculate the manual and percentage performance.
We have created one space by using one cardboard, sir. So we tested with both manual mode and autonomous mode. Actually, initially we filled total space with sand. So first we calculated that the floor area. After that we performed the work. So after cleaning, so we observed the cleaned parts, clean space by measuring the that area. So approximately it came to 90 and 87. So in manual mode will give actually better, around 8 to 10% better results. No, madam, didn't. Actually, initially we thought to design, but unfortunately we didn't calculate. Thank you, madam.
Thank you, sir. Now I invite Mr. Pranay Chitimalla with paper ID 42 titled Design, Material Selection and Finite Element Analysis of a Sensor Package Housing for Avionics Systems.
Both are the presenters. Good evening to all. As per our research, we have done research on modeling and design analysis of sensor package housing. So it is used in the avionics and aircrafts and missiles for the navigation purpose. Generally, we know that navigation is important for the better life, and in avionics, navigation is used for the targets. Like when a missile or any aircraft going from one place to another place, it should go to the target. For that target, we need navigation in them. Generally, we all know that we'll use phones, GPS for our navigation purposes. In avionics and aircrafts, they use both type of navigations. One is GPS and another one is INS, which is inertial navigation system. The GPS itself works on the satellite purpose. And without satellite, we can't able to track or go for the navigation. When it comes to INS, it works on this sensor package housing, which consists of the accelerometers and also the gyroscopes, which are helpful for the navigation purposes. So why we need this navigation betterly? To enhance the in warcrafts or any other missiles, to enhance the navigation purposes. Like when any other hurdles or any other wars, if the GPS has been destroyed or there is no ability of GPS to track the navigation or any other things, they use the INS because it is works on the latitudes and longitudes, and it's completely mechanical. So this sensor housing package is much more important in every missile and aircrafts and all other avionics systems. So here we have done the first, our methodology is design of a chassis and housing. After that, the selection of material and model analysis and also the static analysis. Firstly, the design of chassis or housing. We have taken the aluminum alloy rod as our material, and also for the design purposes, we have this is our design. This is the sensor package housing, and we have analyzed it on it. So these are the parameters of the design. Rest of it continue with my friend Pranay.
Hello. Good afternoon, everyone. So, for major important values for our sensor housing package material is modulus of elasticity, Poisson's ratio, and mass density. Those values should meet as shown, where modulus elasticity is 73 gigapascals and Poisson's ratio 0.33 mass density is 2795.7 kg per meter cube. These three should be the required values for our selection of material. And these three materials match with the our chosen material, aluminium 2014, annealed, in particular it's annealed from. So next, for after selecting the material, we perform the model analysis to ensure our next process. In model analysis, the package bottom surface is all the 16 mounting holes are constrained from translating and rotating in motion. Yes, sir. Yes, sir. Constraint approach. So we couldn't get the boundary conditions figure, sir. Yes, sir. We are still researching, sir. We are not completely. Yes, sir. Yes, ma'am. Yes, yes, yes. The main constraint we applied for the model analysis is the holes are restricted from translating and rotation in motion. Uh, yes, sir. And after performing the analysis, we have gained the required mod shapes and frequencies. So basically, what are these? Sir, this is static analysis. We will go through with that also. Uh, Newton, sir. So in these mode shapes are particularly tells us the formation or the pattern of the sensor housing package excited at that particular frequency. So at this mode shape one typically represents the first mode of the vibration. So according to the information gathered from our IIE Bangalore, we got that the basic range of the frequency should be 360 hertz for testing. But for this model, we got the first natural frequency value 5491.73 natural frequency. Yes, sir. So that mode one is the deformation pattern, and that deformation comes when the excitation happens at 5400, as I listed before. Next, after this, after we ensured that the model is safe as it does not near to the 360 hertz according to the standard, then we perform the static analysis, taking the standard weight as 400 newtons, as we have listed here. Ma'am, when for this particularly navigation in avionics, the standard frequency is 360 hertz. When if the our gain natural frequency is closer to the 360 hertz, then we have to redesign the model. It will undergo resonance and the design is not safe. But our first gain natural frequency is around 5400. So it gives us the assurance. Yes, ma'am. So it gives us the assurance that it is safe.
It's below. It's the design as a any other damages or any other proper. We have to design it, redesign.
So yeah, after performing the model analysis, we went through with static analysis, where we applied the same all the 16 constraints. Uh, uh, we have constrained them from translating and rotating in motion, and we have applied 4,400 Newton. the result static analysis figure result. So for this, we have to achieve the factor of safety greater than 1.5 as per the standards, so that the design is safe. After calculating and performing the analysis, we reach that criteria that ma'am, we have derived we have gained this result. So yeah, when we have achieved the static analysis and the required criteria fits into it, then therefore we concluded that the design model is safe yet till a performed analysis. Yeah, that's it.
Please tell about the conclusion.
Yes, sir.
Just
Yes, sir.
doing it. We have to read it.
So after performing the static analysis and model analysis, we achieved the factor of safety greater than 1.5 and natural frequencies are in the safe criteria, so that based on this result, the design is suitable for the advancing to the next stages, which also comes includes vibration test, physical tests. Thank you, sir.
Any questions you can ask, please.
A good presentation, Pranay. One more, both of you. Can you go to materials slide?
Yes, ma'am.
Yeah, here you said clearly that we have selected aluminum 2014
Yes, ma'am.
because we need to have so and so values for modulus of elasticity, Poisson's ratio, and
Yes.
mass density. Then how you have arrived at these values?
Basically, for this navigation, the model has to focus on the stiffness rather than the strength. So when the standard criteria is 360 hertz, we would know about the values which might not fall in that area. By through our guide and by the information we have gathered, we selected these values.
Actually, with some experience in the avionic packages, I'll say you that there will be some design calculations in this. You need to put it into that design data book from where you will take standard ASTM standards, and you can just improve this, I say.
Okay, definitely.
Thank you.
Thank you, ma'am. Thank you, sir.
Next paper is by Naveen Reddy with paper ID 46, titled Exploring Energy Harvesting Through Piezoelectric Materials. Podium. Please go. Be comfortable with that matter.
Good afternoon, everybody, respected sirs and teachers. Here we have a review on piezoelectric material, how the energy is generated from this piezoelectric material. It is a new topic for us too. It is beyond our theoretical knowledge. So our abstract is generally about how the energy is generating from the piezoelectric material. We will describe about what are the different materials we have used. We have just reviewed of this for generally now. The applications, we will highlight those applications. And usually this piezoelectric material starts at, they were discovered in 1880 And they started researching about this in 1992, and still the papers are going on, researches are going on still. This usually focuses on the sustainability. So our journey started like this. We found the usage first, and then we found the solution. The usage, first we have the different power sources, generally non-renewable, and the world is running towards the renewable one. But the renewable is also not yet fully described, because I have mentioned that in the solar we have high maintenance cost. The open area we should have, and when the sun is out, we can't produce using the solar energy. And if you compare to hydro too, it disturbs the ecosystem around the water sources like dams. If come to biomass, methane energy is produced. So we are not yet completely into the sustainability. And here the solution is the piezoelectric material. As I said, started from 1992, and still the researches are going on yet, but not completely we are sustained on it. What generally I can say is, see, normally the sources are like human body, human motions, and automobile vibrations, domestic and industrial vibrations. They are still unharnessed energies, but energy is coming from them, but we are not utilizing them. So the solution is this piezoelectric material. And as I mentioned there, the batteries will also fail at 60 degrees. We need to produce some, we are using PCM, right? Phase change materials and all, but whether we can replace them with the piezoelectric materials. We can say, why can't we use just a gear mechanism and harness the energy? Yes, we can, but the using of this piezoelectric material is that they are compact and lightweight. That this is the gear mechanism. Generally, that produces the energy. Connecting some motor and the gear mechanism, we can multiply the energy. Whereas this is the piezoelectric material. See what, which is just a compact and lightweight, which is not complex, a simple one. The main concept we are choosing into piezoelectric material is that we can harness the energy from small scales. We are came to know that using our eyelashes too, they can produce the energy. With heartbeat too, they can produce the energy using this piezoelectric material, but they are small amount. They are silent operations, and they are eco-friendly. Usually what happens here in this piezoelectric material is, first we need to apply the mechanical stress. Because of the application of mechanical stress, that mechanical energy is converted into the electrical energy. But we still need optimizations. We found in some papers is that they are using nano generators and all, transducers, which is not up to our level standard of understanding, but we tried our level best. And these are the concepts we need to have a thought on, so that we select the material of these piezoelectric materials. We will elaborate those few piezoelectric materials in further. This anisotropic characteristics is that changing the position of the piezoelectric material too, we can generate the energy. If we place in vertical, they produce some type of electrical energy level. So position also matters. These are coupling coefficient is like how efficiently the mechanical energy is converted into electrical. So these are the characteristics we need to optimize in the materials. So the materials are.
So these are some of the materials that we have gone through, and quartz is a naturally occurring one, and it exhibits piezoelectricity due to its crystalline structure, and it's used in sensors. And PZT stands for lead zirconate titanate, and this has a drawback that lead is being used, which is not environmentally friendly, but it exhibits exceptionally high piezoelectric coefficients, and so therefore it is used in commercial sensors, actuators, and energy harvesters. PZT5A, it's another variant of PZT, but has some better piezoelectric coefficient. D33 is a parameter to measure the piezoelectric coefficient, and it is basically measured in picocoulomb per Newton. It is used in industrial and military applications. And so the world is looking for better alternatives like the lead-free ones, which are to be used in biomedical industry, etc. And so the need for KNN, BT, and BNT has been seen. And the advantage is that this doesn't contain any lead, and then therefore can be used in biomedical devices as well. And piezoelectric polymers and foams are also lightweight and cost effective. They can also be used to produce electricity, in curved surfaces as well.
So we have here we have few applications where piezoelectric materials is mostly used. So first one is harvesting energy from human body. So we can use piezoelectric materials on clothes and shoes. So we can use that, and we can also use as a pacemaker piezoelectric material. So piezoelectric material. So we can use a physioelectric material by placing under the shoe. So Nike company also did that. So they are producing electricity by under the shoe, and we can use that energy by charging watches, etc. And physioelectric by animals, we can place the physioelectric materials by their movements. We can produce some energy, and physioelectric vehicle, by placing piezoelectric material on a vehicle tires, we can produce electricity. So we conclude that piezoelectric is very useful, and from 1992 to present, everyone is researching about the piezoelectric material. Because of the climate changes, we cannot depend upon the renewable energy. So this will be the future piezoelectric material. This will be the new revolution for the digital era. And these are the few challenges we are facing in producing high voltages, and spring placement and adjustment, and materials. So trying different materials, we can produce more electricity, and geometrical modifications. So this is the procedure we are following to make more better. And these are the references we are referred. And we thank our mentor Navin Reddy sir and Bhanumati sir and Anurag University for giving this opportunity.
Exploring energy harvesting through piezoelectric materials, right? So how that energy harvesting is done, I think that's not clearly explained. Yes, you put an application, but how that thing happened, what is the mechanism, that's not explained clearly, I think.
The property of the piezoelectric material itself, sir, due to the application of this load, the charges will disturb. So that the normally the positive electrons, negative electrons are generally at their stable stage. Due to the application, they are disturbed. Hence, the voltage and electricity pass.
So that somewhere you are not showing it clearly in your slide. So that is a main thing. And how much energy you can harvest here that you can apply it continuously? For example, you are telling that shoes one, no?
By two steps, we can produce 0.25.
Really? So that how you are going to connect it to your
By changing different materials, we are trying on it, sir, by keeping.
but piezoelectric is one of the oldest material.
Yes, sir.
It is from 30 years onwards it's there. Now you got many more materials, smart materials, shape memory alloys, so many things are there. Okay, good attempt. And I think you are good in presenting. You can be a good faculty yourself. What is your name?
Sarthika, sir.
You are trying to explain better. Huh? Good. Keep it up.
So I have one doubt. You mentioned about the PCM and piezoelectric, and you want to replace PCM with piezoelectric, or what?
Up to extent as they are, we need.
Please, can you please explain that?
Just a statement I have passed, sir, but not into research.
So, which are better, piezoelectric or PCMs for solar, for this kind?
They both have limitations, sir. The piezo, which until we have referred some few papers, they are only point, not numbered micro watts of power are generated. So coming to PCM, patient material, we need coolant. So depending on the application.
Okay, good. Nice try. Good. Okay.
Go back.
No, this one. See, you said development of conventional as actually the extension of what sir is telling. When you are saying, go back a little bit, one more slide. When you are saying that you can extract energy from every bit of human, action of human body and all, you have to connect it to some energy extraction and to what you can apply, how much you can apply. If you show like that, that will be more useful.
How you store?
Yes, how you store and where it can be applied, for how much duration you are able to extract all that. See, the energy always generation is not consistent and constant, no. So that also you should actually research on that also, especially duration. Right?
Any questions from the audience, please? Okay, thank you.
Thank you for your input, sir, ma'am.
Next, I would like to invite Munita Anuja Ananta ma'am with paper ID 29, titled Identification of Optimal Machining Parameters to Improve the Surface Finish of AL7075 SICMOS2 Hybrid Composites Adopting Taguchi's Method. Ma'am, please.
Good evening, respected professors and my dear students. This is Dr. A. Munitanuja presenting before you my work with the title, Identification of Optimal Machining Parameters to Improve the Surface Finish of. So basically, this is a hybrid composite material with the base metal as AL7075, which find various applications in marine industries, many aerospace and automotive applications it has. So coming to reinforcement materials, silicon carbide and molybdenum disulfide have been chosen. Basically, this is the work from Dr. P. Sarita Madam. So a part of her thesis was chosen here and it was presented, that is by employing this Taguchi method. How the various parameters can be optimized, process parameters can be optimized through the Taguchi method. So going ahead with my abstract. So what are all the various machining parameters that I have considered are cutting speed, feed rate and depth of cut. And moreover, one more parameter under consideration is the percentage, the weight percentage of silicon carbide, that is considered as 5%, 10 and 15. And then molybdenum disulfide, it was fixed, that is 3%. So now by employing this modified Taguchi approach, so I want to introduce you this approach. So this approach was basically developed by my guide, Dr. B. Nageshwar Rao sir from KL University. So he has developed this sorry. There is a light. Okay. Dr. B. Nageshwar Rao sir, he is my guide while I was performing my PhD at KL University. So this approach was developed by my guide. So based upon this approach, so I have considered single objective optimization, that is with respect to, I want to reduce the surface roughness of the given composite material, which has been subjected to turning operation. So coming to the optimal machining parameters, whatever I have obtained is the cutting speed 140 and then feed rate 0.1 mm per revolution, depth of cut 0.9 mm. And moreover, so the measured optimal set for this measured optimal set, so I have obtained the surface roughness as 1.41 and then 1.423, which are almost very nearer to each other. So this is my work in precise. So going ahead with the introduction part. So whatever the material that is in the form of rods have been produced through stir casting process and characterization has been done. So it was like all the parameters, like output parameters, I have so many parameters, but I have considered only surface roughness since it being a single object optimization technique I have employed. So going ahead with the application. So what are all the various applications with respect to metal matrix composites of this aluminum? So it has innumerous applications. These are the manufacturers. So with the basic base metal as aluminum 7075, these are the various applications. So this is the main reason why this work has been focused on considering those, the reinforcement materials are silicon carbide and molybdenum disulfide. So going ahead, the experimental setup, as I told, the manufactured rods have been subjected to CNC lathe machine turning per operation. And this is one with which we have measured the surface roughness. So the output parameter and 3 input parameters and one more parameter that I have chosen, that is the variation of the weight percentage of silicon carbide. So going ahead with this modified Taguchi approach, I haven't focused much on the experimentation part. So I'm just entering into the analysis part. So whatever, when I was a scholar, whatever I have faced, my own experience is the work can be performed by anyone. We are ready with going ahead with the experimentation part. Wherever we lag is publication. I just want to explain my own, feelings about research. So the thing is, we lag the experimentation and moreover, not the experimentation part, the analysis part, we lag in the analysis part. So maximum we'll try to reduce the number of experiments. So with this 9 set of data, whatever do I have produced. So this is the L9 Taguchi array. So through the levels, whatever I have considered for the 4 parameters, considered parameters, that is cutting speed, feed rate, depth of cut, and silicon carbide, proportion of silicon carbide mixed with it. So basically, so this is the number of experiments that we have carried, that is only 9. And then the number of parameters to be considered. NP stands for the number of parameters to be considered, and NL, the number of levels to be considered. The number of levels are pretty clear, that is 3. And then the number of parameters that I have considered, we need to consider 4. So how many experiments do we need to carry actually? 3 power 4, 81. We have to carry on 81 experiments in order to calculate what is the optimal combination where I can able to reduce the surface roughness of the given, whatever the material do I have. So in this case, so I can't offer 81 set of experiments. It is very costlier. So whatever the data that they have, experimental data that they have with this combination of parameters. So this is the data. If you check, only 9 set of experiments were carried. Now, so this is the additive law, whatever it was employed. So that is pi. Here, this is the surface roughness. I have considered it as output parameter, output response, that is surface roughness. And pi g stands for the grand mean. Pi I stands for the levels. That is the levels I have considered as 1, 2, 3, 4. So this is the mean value of whatever the parameter that I am considering. Like the 4 parameters that I have considered A, B, C, D as speed, feed, depth of cut, and the percentage weight of silicon carbide. So if I go ahead, so I can show you the analysis part also if you are interested. So this is the analysis part. How to open it? Can I go to next slide? So based upon this ANOVA results, whatever I have got, the sum of squares has been calculated. From this, we can say that the percentage contribution A stands for speed, cutting speed, and C stands for depth of cut. So they pay the maximum contribution compared to the other 2 parameters. So going ahead, the reason is basically whenever we are performing turning operation, speed and moreover depth of cut has maximum values of contribution. Like they have the better way of improving those results such that we can able to get the super fine surface finish. The percentage contribution, sir. The thing is, we need to more concentrate on these 2 values in order to get surface finish to the maximum level possible. Yes, sir. The percentage contribution means major role. So going ahead with, so whatever we have seen here, the basic first empirical relation, that is with respect to the additive law, the basic additive law. Whenever this additive law is applicable for our surface roughness, that is the output parameter considered. So this is the equation, or I want to say that as empirical relation that we can able to. Okay. Okay. So through the calculation, so the grade, so the mean value, the grade mean value has been obtained as 3.26 micrometers. And then, so this is the basic empirical relation that we can able to obtain. So this zeta 1, zeta 2, zeta 3, zeta 4 are the ones. So we have 4 parameters, right? That we can able to obtain all those parameters through cutting speed, feed, depth of cut, and the percentage, what to say, the weight of our silicon carbide. Okay. So based on which we can able to obtain this empirical relation. Now we need to check, we need to validate our results. The 81 results, whatever we got through those 9 set of experimental results, we need to validate through this empirical approach. So I'll show you the data also. So why I have considered from this 81, you can check I have gone up to 32, and in the next it is up to 65. These are the combinations, only these combinations shoot my experimental results. We can able to compare the experimental combination with this, what to say, some 27. Though we have calculated 81, but those are only applicable, like I can able to compare my result, whatever I have got with this one. So going ahead, like the results comparison of our surface roughness. So that, as I already told you, the empirical relation, whatever I have obtained compared with the additive law, I can able to generate the graphs. You can see how closer they are. So that is through additive law and through my empirical relation. That is the third equation, whatever I have shown you. So this is one more, that is with respect to test data and my empirical relation. So they are very closer if you check. And this is the one which shows that whenever I keep increasing the percentage weight of silicon carbide, so my, what to say, the surface roughness has been increased. No, ma'am. The reason is they have gone through certain incremental steps of 5, I feel, because the experimentation was already carried by them. We have taken a part from that in order to apply our own approach for it, such that we can able to obtain. Yes, sir, exactly. She is the first author. Okay. Yes, sir, might be. Yes. Through literature review, she would have. Yes. So this I have shown you already. So coming to conclusion part. So as I told, it is with the few experiments also we can able to generate the data and we can obtain the maximum possible output, optimal combination. So the comparison, as I have already shown you, the increasing trend, it has been shown for the varying weight percentages. So this is the optimal combination, whatever I have obtained. So with 5% of silicon carbide, 140, 0.1, 0.9. So the measured value, as I already told you, so it is 1.41 micrometers and 1 point, I can show you that also. So this is my 20-second. 3, 2, 1, 1. With that combination, I can obtain 1.41 through the experimental value. And whatever the one which we have calculated from the empirical relation, it is 1.4233. They are very closer to each other. So saying that our empirical relation, whatever we have developed, is very near to the experimental value. Thank you. These are my references. So open for discussion.
Hello, any questions from the audience?
Answer to sir. Some percentage contribution is depth of cut has got more contribution compared with feed rate.
Compared to feed rate.
That's why that percentage is different. And one more, why that difference means it is due because during experimentation, some oxides are formed during the process. Those oxides reduce the surface roughness, sir. So that's why we get different surface roughness values also. Yeah, that is exact one.
Yes, sir. I haven't gone through much on that, it being the work from ma'am. So we have applied our own approach for it in order to obtain the. No, frankly saying. It's madam's work. We have applied that approach. Yeah, thank you, sir. Thank you, Vanana.
Thank you, ma'am. Now we have the last paper of our session by Akula Neeraja ma'am with paper ID 59 titled Design and Analysis of Graphene Coated Square Designed Mold Machining EDM Electrodes Using ANSYS. Thank you. Paper ID 59.
Yes, good afternoon all. This is myself, Mrs. Neeraja, from Mechanical Department, Anurag University. My paper title is Design and Analysis of Graphene Coated Square Design Mold Machining EDM Electrode Using ANSYS. This is sorry. This is my abstract. Right, designing of electrode and designing of mold cavity in the new software that is significant for the electrode, significant for the EDM electrode. Actually, that is Symmetron software. In that, various modules are there. So in that, I have taken the module of electrode preparation module and mold cavity preparation module I have taken. And that module, and after designing this electrode and model cavity, I've imported this to an ANSYS workbench. ANSYS workbench, I've selected the module as thermoelectric module. So my work is at mold cavity finishing operation using a different electrode design. For that different electrode design, I have taken, instead of taking a solid solid graphite, I've taken the graphene coated polymer electrode as a electrode. In that experimental results, I have validated this result from the experimental results. That tool wear rate I've validated from the experimental results. I got 5% variation I got from the experimental results. This is the introduction. EDM machine, we all know that it is mixing of a tool and workpiece. And EDM machining, it removes the material from the workpiece using it by means of electrical discharge. And this, I've taken the graphene, because graphene is taken because of it has high machinability and thermal conductivity and electrical conductivity. And it is popular for EDM electrode. Right, and next I've taken that introduction of Symmetron. Symmetron is a significant for designing of EDM electrodes and mold cavity designs also. And during the design, we can give, it is specially for designing of complex designs of electrodes. And during the electrode design, we can also give that EDM properties also. EDM properties like a spark gap and EDM current on time, pulse on time also we can give during the design of electrode. And designing of this electrode, yes, before. Oh, sorry. Okay. Sir? Yes, okay. So significance of work, in this significance of work, I've used the Symmetron, designing in Symmetron, and that imported to the ANSYS and thermoelectric analysis I've done. Right, and this, okay, this is the related work, okay, I'm just moving. These are the objectives. My simulation estimate the discharge current effect on the electrode areas and where flux deposited for causing the wear, and through flux, through heat flux that causes the wear, and through that I'm estimating the tool wear rate. And the field intensity and joule heat discharge on model electrode also. Next, third objective is birth and death conditions to check the maximum contact wear on the electrode. So these are the three objectives, and this is my workflow. And design of mold cavity and electrode, both are designed in a Symmetron. That is the Symmetron software. And next, I have applied the material for the electrode and material for the workpiece. And discharge conditions also I've selected and during the design. And next, next is import the electrode design to the thermoelastic module analysis. And next, I have in ANSYS workbench, I have given mesh and boundary conditions. Then I have analyzed the results. And material assignment I've given as discussed, I've used the graphite coated electrode. So physical graphite coated electrode, those properties I've taken for that simulation purpose also. These are the properties of graphene layer coated polymer electrode. Workpiece, I've assigned selected a material for the workpiece is H30 steel material I've given for the multi-cavity mold. So these are the design of a mold cavity. So that cavity, that is mold cavity, right side one is mold cavity, and design here 10 mm square I've taken, and 2 cavities are provided for the this workpiece. And this we are designed in Symmetron. So while during the design, I've given the spark gap is 0.05 mm. So this is Symmetron electrode selections. Electrode selection, I have taken the same electrode design. So I've selected the surfaces also, selection of cavity area for heat flux generation, and selection of electrode surfaces, selection of head and electrode area. And for designing electrode, I've taken the ISO standard tool electrode design, and spark gap selection also taken. That is 0.05, and graphite assignment and material assigned to the design. So this is ANSYS input parameters I've given. On time, the pulse on time I've given 10 seconds, and temperature after dielectric addition is 235 degrees I've given, and current 25 amperes, voltage is 50 volts, and contact surface temperatures when you are after selecting the contact surfaces, I've given 1200 degrees as a temperature, and spark gap is 0.05 mm. So this, after designing this, imported into ANSYS, here meshed the workpiece and electrode as well as I've meshed the geometry, and that I've provided the elements and nodes for the workpiece and electrode. Okay. Yes, 3D component only. 3D component, that height I've given. No, a triangular mesh. I've given triangular mesh with a 2 mm. The element size is 2 mm, and the size is triangular mesh. Shape is triangular for both workpiece and electrode. So contact areas I've selected. Contact areas of electrode and contact area of this workpiece cavity, mold cavity. So these are the results, and where a tool where evaluated through the heat flux, right? The main cause of electrode wear is due to the heat flux I've taken. The carbon formation is also estimated in EDM, right? The formation of workpiece in contact area is very less. It observed in a workpiece. Right side one is the workpiece. Workpiece cavity observed in that ladder is that blue one. That is a minimum heat flux formed on the workpiece. And when comes to the electrode, some minimum heat flux are formed in the face contact area. We are observing here. The minimum is okay 0.3 this thing. So that the contact area we have observed through this heat flux. We are estimated that tool wear rate. Right. This current density also we are observing this current density and electrical intensity also. That the current density is maximum at the head of the tool, and here also the electrical intensity also for the given conditions for the given parameters. So this particle erosion clearly shown in figure, and this is electrode at the head we are observing. In this, the red color one is the erosion material that we are observing, and maximum heat flux deposition and carbon deposition at that point. the maximum wear found at the red locations, and then in that diagram. So it is based with a dielectric fluid. We have taken the EDM oil as a dielectric fluid, and only the single direction we have taken instead of using a the double directional. So these are the conclusions from my work. Conclusions are the temperature distribution we are estimating and material removal process efficiency also increases the EDM process, and the results shown the result electrode wear rate as effective in limiting formation of the flux in a workpiece, and overall electrode wear is quite minimal, what we have observed in the previous figures, and designed electrode floor area remains unaffected, that we have seen. It is concluded that most of the flux formation is at the electrode edges, and the design electrode floor area is not affected significantly by selected voltages, voltage and current, that what we have assigned. Electrode floor area and current density and viscosity of the coolant, what we have used are important considerations. So important considerations in that coolant I've used dielectric as EDM oil for when optimizing the electrode for affecting the cooling and shocking proofs. And the next conclusion is by applying the same condition for experiment work, the heat flux deposition in corners, what we have observed is up to 0.35 after machining. The present analysis, in this analysis and simulation, we got heat flux value is 0.32 maximum, that is, right? The variation is up to approximately 5% we have observed. So because of some practical losses, we have not considered maximum accuracy level. Through that, I am telling the approximately 5% variation from the machining, physical machining. Okay. With the same properties of graphite coating, sir. Without, we have not. That previous papers you have seen for the same one. Okay. Okay, sir. And future considerations or future recommendations are this, and dielectric fluid you can change and change the various dielectric fluids also instead of EDM oil, and single direction flow we can also use a dielectric flow also, dielectric flow. So that these two are the future considerations. Future recommendations. Any question? The square is 10 mm, 10 mm, and two cavities are provided. 10 mm. So it is difficult to do machining in conventional, madam, and simulation, but so this is somewhat complex method. We can use any complex shapes. So this is only the basic simulation. We can do any complex shapes using Symmetron software. But if we can go for conventional also, but it is the cost effective for designing. Any questions?
Just one question which you have already answered. Why you have chosen Symmetron software?
Symmetron is just significantly related to the EDM electrode designing. So we can also give during the design, we can also give the EDM properties directly. So spark gap, so workpiece and electrode gap between these two, right? 0.05 given. While designing only, we can give that EDM parameters directly. There is no other software for this. It is not free software, it is licensed. Any questions?
As we are about to conclude the day one, does any one of the participants would like to give the feedback for the day one of the conference or the proceedings that have been? No. Sir, please.
Good evening, everyone. Actually, it's my first conference, my first paper. I can't compare with other sessions, but my experience is I'm happy because the organizing team and collective support and coordination I have seen. So thank you, everyone, and thank you, ma'am.
Good evening, dignitaries and dear participants. As we conclude the first day of the international conference, I want to take a moment to reflect on what an inspiring and engaging day it has been. Today, we have witnessed a wealth of knowledge shared through thought-provoking presentations, insightful discussions, and innovative ideas. I would like to extend my heartfelt gratitude to our keynote speakers, Dr. Nitin Muttil sir and Professor L. Shivaramakrishna sir, and session chairs. I would now request the session chair, General Chair, Dr. K. Srinivas Chalapati sir, ICIFMEDE convener, Dr. Sikindar Baba sir, Dean SOE, Dr. V. Vijay Kumar sir, to felicitate our session chair, Professor L. Shivaram Krishna sir. Sir, please come on to the dais. Pratibha ma'am, please come on to the dais. Thank you, sir. Your contributions have set a high standard for the discussions we will continue tomorrow. As we conclude day one, I encourage you all to reflect on the insights, network with peers, and prepare for the exciting tomorrow. We have equally stimulating agenda starting at 9:30 a.m. tomorrow at the same venue with keynote session of Professor V. Vasu from NIT Warangal. Now I request all the faculty members to come on to the dais and the participants for a group photo.
Outside, followed by.
Thank you once again for making today such a great success. After the photo session, I request everyone to join for a tea break. Sorry, high tea. High tea.